Hello all, this video is on 8051 UART serial communication. This 89S52 has got UART pins at port 3, that is port 3.0 is RX pin and port 3.1 is at TX pin. And on board there is RS232, that is max 232 IC to convert it into RS232 levels. There is a DB9 connector to which you can either use a DB9 RS232 to USB to connect it to PC and test it using serial monitor, or while using a GSM or GPS module like this, you can connect it with the DB9 connector using DB9 cable. Now let us see the serial communication, which is called UART in 8051, that is Universal Asynchronous Receive Transmit, and it uses no clock. There is a start bit which is usually low, and after that 8 bits D0 to D7. D0 is the LSB and it goes out first, and D7 is the MSB which goes out last, and after that a parity bit is there which is optional, and finally stop bit which is usually high. So this use of start and stop bits to control the transfer of data is called framing. And after that stop bit, if there is no transfer, then the signal is high, which is referred as mark, and low is referred as space. The rate at which serial communication takes place is called baud rate, which is bits per second. Now let us start with a new project after creating a folder for UART testing. Inside this folder, let us save the project and then select the IC 8089S52, and then in the project window the project is created, and target, right click target, and settings for the target, options for the target, change the crystal value to 11.0592, and then output, you put a tick mark against create hex file and confirm that under debug simulator is on, and right click on source group and add new, and then click on C file, provide a name for the C file, and then click on add. Now in the editor window you can feed in the code. Now let us see the code first and then explain the registers. In this video we will not be using any hardware, only a simulator and theory. So start with hash include reg 52.h header file, after that void main void, and then SCON equal to 0x50, that is a SCON register, serial control register. After that TMode, we are giving a value of 0x20, and TH1 register is loaded with 0xFD, that is for 9600 baud. We will see one by one registers after finishing this code, and after that we enable the timer using TR1 equal to 1, and then the SBUF register is loaded with character A, single character, and we wait till the transmit flag is set to 1. And then we clear the transmit interrupt flag, and then the while never-ending loop, inside that nothing, no code is there. Save this and then build this. Now let us rearrange this code in functions for easy understanding. So inside the void main, we'll create a function UART underscore init. This is for initializing the UART, initializing the registers of UART. So we'll do the function declaration at the top, and then go below the void main function and create the code for this UART underscore init. Now let us cut this SCON TMode, this settings, register settings, and paste it here. This 4 lines, let us paste it here. This is for UART init, and then we'll call from the main function, and after this UART is initialized, we'll call the function for transmitting character A. name this function as UART underscore TX, and before void main, let us do the function declaration void UART underscore TX, and it takes a parameter which is unsigned char. Let us name it as X. As you are transmitting a single character, we will use a char data type. And inside the code for the function, let us cut and paste these 3 lines from sbuff. That is, we are going to send a character A. So paste these 3 lines of code inside this UART underscore TX function, and sbuff equal to, let us make it as X, so that while this function is called, the parameter is passed on. That is, the character A is passed on while the UART underscore TX function is called. Now let us rebuild this code to see if any errors are there. So before simulating the code, let us see the registers and why these values are alerted. First register is SCON Register, which is serial controlled register, and it is bit addressable. So each bits can be individually addressed. The LSB bits SM0 and SM1, they decide the serial port modifier. That is they decide the type of serial communication. Total 4 types of UART communications are there, and these 2 bits which are the serial port mode specifier, they decide the type of communication, and we select mode 1, which is 8-bit UART, and the baud rate is determined by the timer 1. This is variable baud rate is possible while setting this mode specifier. So we select mode 1, and the next bit SM2 is not used, that is for other modes, and the D4 bit is REN, this is receiver enabled bit. It set it to 1 to enable reception, and if you want only transmission, you can make it as 0. Here we will make it as 1. And after this 2 bits, TB8 and RB8, this is for other modes, so we will leave it as 00. And after that, TA and RI flags, transmit interrupt flag and receive interrupt flag, that is set when TA will be set when TX is completed, and RI will be set when the sbuff is full and receive is complete. So let us leave it as 00. So finally, when you calculate this binary, it comes to 0x50 in hex. So if you want only transmit, make it as 0x40. And the next one is the TMode register. TMode is timer mode control register, and it has got 8 bits. This is not bit addressable, and it controls 2 timers. That is the usage mode of 2 timers. The lower 4 bits for timer 1 and the upper 4 bits for timer 0. We will be seeing for timer 1. So let us see the bits for lower, that is the MSB bits. Gate, first bit is gate. So when it is 0, we can start and stop the timer by software encoding. So let us leave it to 0. When it is set to 1, then the timer is controlled by hardware by interrupt. And the next bit is C bar T, and when it is cleared, timer operation is it is for timer operation and the input from internal clock, and when it is set, it is for counter operation. The input is from TX input pin. And next 2 bits M1 and M0, that is for timer counter mode select. There are totally 4 modes. We will be selecting the mode 2. So the M1 will be 1 and M0 will be 0. So this mode 2 is 8-bit auto reload mode, and we will be loading the TH1 and TL1 register for baud rate calculation. That we will see next. So the binary calculation will be 0010, and for timer 0, all zeros. It comes to 0x20 hex. So we load the TMode timer mode control register as 0x20. This is for setting the timer 1 in mode 2. And next is the TH1. TH1 we load it with 0xFD. This decides the baud rate. So there are 2 8-bit registers, TH1 and TL1. This is for timer 1, and each totally it is 16-bit. Actually these timers are all 16-bit. So TH1 is 8-bit, TL1 is 8-bit. Let us see how the baud rate is calculated. Crystal we are using is 11.0592, and the 8051 circuitry divides it by 12 to get the machine cycle frequency. So 11.0592 divided by 12 will be 921.6 kilohertz. And the 8051's UART circuitry further divides it by 32. So to get a lower baud rate, this division is must. So this 32 is a standard division, and finally we get 28800 Hz. And this is used by timer 1 to set the baud rate. So timer 1 is the baud rate source. So this 28800 is used by timer 1 to set the baud rate. So for example, we want 9600 baud. So 28800 by 9600 equal to 3, which means if the timer counter ticks 3 times, it generates 9600 baud. So for every 3 ticks, this baud rate is generated, 9600 baud rate is generated, bits per second. So generally we can count from 00 for 3 ticks, but here we start with the maximum value. So it is 8 bits, so the maximum value is 255 decimal, which is FF. We have to take into account the overflow also. After FF, the counter, the timer will overflow. So from overflow, if you calculate from reverse, from overflow to FF 1 tick, for the next tick FF to FE, and the third tick FE to FD. So if you load 0xFD to TH register, as it is in auto reload mode, the TL register will be automatically loaded with FD, and when the timer is on, it starts ticking. So FD to FE, then FF, and then overflow. So for every 3 ticks, the TL overflows and the baud rate is set. This is for 9600 baud rate. So for other baud rate, this is the chart. So TH register will be loaded with 0xFD for 9600 baud. You can also use the decimal value -3. So if you want a lower baud rate, still lower baud rate, 4800, then you have to load FA for 2400 F4 and 1200 E8. So this is the baud rate calculation, and we use the TH register. Timer 1 is used in mode 2. Then we make the TR1 bit as 1. So this is from TCON register. The TCON register is a 8-bit register, and it is bit addressable. So either you can use it as a byte TCON full value, you can give it as 0x40, or only that D6 bit is set, TR1 bit is set, and you can individually make it as TR1 equal to 1. You can either use the full TCON register also. Here we are using only the bit TR1 equal to 1. And under the void UART underscore TX, we call the SBuff register to send the character. So this SBuff register is a 8-bit register, and there is a separate SBuff register for TX as well as for RX. For RX, the inside there will be a shift register, and then it will go to the SBuff register. And then we wait till the TI flag is set. The TI flag is nothing but transmit interrupt flag. While the transmission is completed, this flag will be set. Once the flag is set, after that we clear it using software. Now let us see the full code. That is, SCON is 0x50, TMode is 0x20, TH1 is loaded with 0xFD, and then TR1 is set, and then the UART underscore TX function is called, where the SBuff is register is loaded with the character to send. And finally we wait for the transmit interrupt flag, and then when the flag is set, after that the transmission is completed, we set it back to 0 so that the next transmission starts. For testing, let us use the debug session. In this demo we are not using any hardware, so let us start the inbuilt simulator, that is a start debug session, and then click on view, select the serial window, and then select the UART 1. So this will open UART 1 window at the bottom. So you can see the character for transmitting under this UART window. Now let us select 2 objects from peripherals. One is the serial channel, and the other one is the timer 1. So two separate windows will be open. Let us align these windows side by side so that while doing the debug we can see the register values. And then the UART window is at the bottom. Now from debug, click on run. You can see a single character A which is transmitted, and it is shown under the UART window. Now inside the serial terminal, you can see the mode as 8-bit variable baud rate mode, and it is set by SCON 0x50, and the transmitter character is A, and it is represented as ASCII. So the SBUF register is loaded with 0x41, that is the ASCII value for A. That is why you see 0x41 in SBUF, and the baud rate is set as 9600. This is by loading the TH1 register with FD, and that is seen in the timer counter window. So you can see here as 8-bit auto reload mode, which is mode 2 for timer 1, as set by the TMode 0x20, and the TH1 value is loaded with 0xFD, and TL1 value we can see while stepping over. Close the debug session and start it again, and then from debug click over step over, that is the F10 button, so that we can see the code running step one by one. So initially from under void main, it will start from void 1, and there is a call for UART_init, where the SCON register is set as 0x50, and the TMode is set as 0x20, that you can see in the serial, that is a timer window. And then the TH1 is loaded as the 0xFD, and then again step over, you can see the TR1 is set as 1, that is a timer 1, that 1 is set, that can be seen under TCON, that is equal to 0x40, that is bit addressable, means TR1 is equal to 1. And then we have a call for UART_TX function, where we pass on the character A to transmit, that you can see under the UART window. So the ASCII for A is 0x41, that you can see in the SBUF, and the baud rate is set to 9600. The SBUF is loaded with 0x41, which is the ASCII for A, which we are transmitting. And click on step over, and it will stop at while. So it will not pass on further, it will stay at while. So this code sends character only once. Now let us stop this debug session, and for repeated transmission, let us place the UART_TX function call under the while function. So while 1, after that remove the semicolon and open close braces, cut and paste this UART_TX here. So under the never-ending loop, we are going to call the UART_TX, so that the character A is repeatedly sent. Now save this file and rebuild. Start the debug session and click on run. So now the previous setting windows will be open automatically. Now if you click on run, you can see the character A is repeatedly sent. Now watch the TL1 register. So the TH1 is loaded with 0xFD. TL1 will be automatically reloaded with FD. It starts with FD, counts to FE, FF, and then overflows. So every 3 ticks it sends the character A. So the baud rate is 9600. Now let us see the code for receive character. So let us start a new C code for this. Let us start with a new project, and later we will mix the transmit and receive code together in the further videos. Now for this receive code, you start a new session, new project, and under the void main void, we set the SCON register as 0x50, TMode as 0x20, same as that we did for the transmission, and the TH1 is loaded with 0xFD. This is for 9600 baud, and then TR, that is a timer 1, is enabled to run, and we wait till the receive flag is set to 1. that is while RI has a value of 0, still till it is set, it will stay there. And after that we use the port 0 to load the sbuff value. The received character will be loaded to P0 port, and then we reset the flag, RI flag. And then the while 1, it is not used here. Now save this file and then build this. It is showing 2 errors. The first error is while after that never ending loop we are not used 1, that we will change it, and P0 is equal to SBUF, we are used to double F, so change that, save the file and then rebuild it. Now there is no errors. Now click on debug and then start the debug session. It is showing evaluation mode. And now from under view, select the serial window and select UART 1. So UART 1 will be displayed at the bottom, and from peripherals select the IO port 0, as the sbuff is loaded to port 0. We'll open that port 0, and from debug session click on run, that is F5 button. Now from under the UART window you have to type in the character. So while typing in the character you will not see anything under this window. So now I am typing A, that is a capital A. You can see the ports P0 is displaying 0x41, which is the ASCII for capital A. Now let us change the code so that it is under the repeated for never ending loop rx_char. So we'll create a function and we'll call that function rx_char from within the never ending loop, so that we can test it repeatedly. Now save this, rebuild it, and then open the debug session. The port 0 and the UART 1 is open as set in the previous one. From within the UART 1, now type in capital B. That will give the ASCII value. Now let us see from the ASCII table. That is, if you type in B, it will show 0x42, that you can see from the ASCII table. Now type in capital C. So the port 0 will display 0x43. You can see the tick mark under the bits section also accordingly. So for if you type in 0, there is a O, you will get 0x4F. Thank you for watching.